Today we're taking a look at section 2.2 on Venn diagrams and subsets. And first of all, we need to talk about what is called the universe of discourse, also called the universal set. This is the set of all things under discussion at a given time. It is different for different problems. In math, we use the universal set that has the symbol U. And very often you may also see more of a script U being used for the universal set. Now, the Venn diagram was a means for drawing the relationship between two or more sets. And so the diagrams were named for them because they were developed by John Venn. And typically what we have is we have a rectangle that represents the universal set, and then we'll have another set within the universal set, and this is going to look slightly different from what you have on your printout because it doesn't transfer to the tablet journal exactly the way I do it in the notes. So if we want to talk about set B, we can take a circle for set B and simply shade it in. Okay, for any set A within the universal set, the complement of A, which is written A with an apostrophe, or you can think of it as an accent mark, is the set of all elements of U that are not elements of A. So the complement of B, if I have the set, okay, I have my universal set and there's my set B. Complement of B would be everything, or B prime. Very often we call that a prime, the apostrophe or the accent mark in math. B prime would be everything outside of B, everything in the universal set which is not in set B. Now let's look at some specific sets if we're going to talk about the complement. Suppose our universal set consists of the counting numbers 1 through 10. Set A is 1, 3, 5, and 7. Set B contains 2, 4, 6, 8, 10. A complement 2, 4, 6, 8, 9, 10. B complement. Okay, and the way we're getting that is we're looking at set A, and we want to list everything we find in the universal set that's not in A. Well, 1 is, but 2 is not, so that's going down here. 3's in A, but 4 is not. 5's in A, but 6 is not. 7's in A, but 8 is not. 9 and 10 are not. So that's what makes up the complement of A. Likewise, we can see if I can erase all of that. We can do the complement of B. Let me find a different color. Okay, so we want to list everything we find in the universal set which is not found in B. Well, there's no 1, so that's where the 1 comes from. We have a 2, so we need a 3. We have a 4, so we need a 5. We have a 6 in B, so here's a 7. And we have an 8 in B, so there's the 9. We have a 10 in B, so B complement consists of 1, 3, 5, 7, and 9. Note that the complement of the universal set is the empty set, and the complement of the empty set is the universal set. So everything found in the universal set which is not in the universal set would be empty. There are no elements. Everything found in the universal set that's not found in the empty set, well, the empty set has nothing in it, so that would be the universal set. Okay, next definition, a subset of every set. A subset, A is a subset of B, and that should be a capital B there, if every element of A is also an element of B. So again, for our Venn diagram, we want to use a rectangle to represent the universal set. And our set B is the larger set. Set A is contained in set B. So we say A is a subset of set B. A is a subset of set B. So everything in A is found in B. That's what we mean by a subset. It says, consider the sets A and B as listed in example 2. A is a subset of B complement, but A is not a subset of B. Let's look back at these. And let me erase my markings on here. Okay, we're talking about A is a subset of B complement. Let's see if that's true. Alright, here's set A. Is everything in A found in B complement? Let's see, the 1 is, the 3 is, the 5 is, yes. So that certainly is true. Is A a subset of B? Alright, here's B. Whoops, nothing in A is found in B. So you want to make sure that you add the slash, because I didn't have that symbol on my keyboard. So you want to make sure you add the slash there. Note that the empty set is a subset of A and the empty set is a subset of B. And this is a very important fact. The empty set is a subset of every set. Now we have a second type of subset. It's called a proper subset. It says A is a proper subset of B if A is a subset of B and A does not equal B. And the way we write it, you notice the line underneath includes the equals. So when we write this, we're not including when the two sets are equal. So if we look back at our example up here, is A a proper subset of B complement? Okay, let me erase. We're not looking at B here. We're looking at B complement. All right, we have, whoops. All right, 1, 3, 5, 7. Okay, everything in, we do have A as a subset of B complement. Okay, and notice A is not equal to B, because a B complement, that is, contains a 9, whereas set A does not. So that means we do have A is a proper subset of set B. Don't want to get too far. Notice that A would not be a proper subset of itself because A equals A. Okay, now the last thing we